Good morning. My name is Fazal Ehsan, and today I am presenting my master thesis research titled Low Temperature Crack Resistance of Hot Roll Aspirin Mixture. My research on understanding how hot roll asphalt behave under low temperature condition and how its resistance to cracking can be improved through the modification in mixture design. This topic is very important because road pavement are continuously exposed environmental and traffic loading conditions. Among environmental factors, low temperature is one of the major causes of pavement distress, especially thermal cracking. Thermal cracking reduces pavement services lives, increase maintenance costs, and affect road safety. Therefore, improving crack resistance in asphalt mixture is essential for creating durable and sustainable pavements. Today, I will explain background of the study, the research problem methodology, result, discussion, and the main conclusion. Overview of research. To begin, hot roll asphalt, commonly known as HRA, is one of the most widely used paving material, particularly in the UK. It is preferred because of its good durability, its smooth surface texture, its strong resistance to traffic wear, long-term structural performance. Despite these advantages, HRA has one major limitation. At low temperature, asphalt loses flexibility and becomes stiff and brittle. When this happens, the material constricts due to temperature reduction. If the stress generated by this construction exceeds the tensile strength of asphalt, cracks begin to form. These cracks then allow water infiltration, which accelerates pavement deterioration. These create serious engineering and economical challenges. That is why understanding low temperature cracking is essential. Now move to the research problem. The specific problem addressed in this research is that traditional HRA mixtures are not allowed to optimize for low temperature performance. Although many studies have investigated general asphalt performance, there is a limited research especially focused on HRA crack resistance under cold weather conditions. These create a knowledge gap. Engineers need more evidence-based guidance in which material combination provide better resistance to cracking. Without this information, payment may fail earlier than expected. This research attempts to address these issues. Now move to research aim and objectives. The main aim of this study is to evaluate low temperature crack resistance of HRA mixture and identify strategies for improving their performance. To achieve this aim, the research was guided by several objectives. The first objective was to review existing literature on low temperature asphalt performance. The second objective was to investigate to influence material composition on cracking resistance. The third objective was to evaluate the performance of different HRA mixture under laboratory testing conditions. The fourth objective was to identify which mixture design provide the best resistance to low temperature cracking. Finally, the study aimed to provide recommendations for future pavement design improvements. Now move to the literature review. The literature review examined previous studies related to the asphalt cracking mechanism and mixture performance. Several important factors were identified. The first factor is a binder types. The asphalt binder determines the flexibility of the mixture. Softer binders generally provide better resistance to thermal cracking because they remain flexible at lower temperature. The second factor is modifier and adaptive. Polymer modify binder and adaptive can improve elasticity and reduce brittleness. The third factor is aggregate structure. The agreement and gradation of aggregate particle affect stress distribution within the mixture. The fourth factor is temperature sustainability. Some mixtures are more sensitive to temperature change than others. Although these factors are well studies for journal aspirant mixture, fever study focus especially on hot roll aspirant. This is confirmed that the importance of my research. Now move to the methodology. To investigate the research problem, I adopted an experimental methodology. The study involved preparing multiple HRA mixture with variation in material composition. This variation includes difference in binder properties, additive incorporation, aggregate gradation. Each mixture was prepared according to the standard laboratory procedure to ensure consistency. The prepared sample was then subjected to low temperature performance testing. The tests were designed to evaluate first stiffness, this means how resistant material to determination, second crack resistance, this evaluates the mixture ability to withstand tensile stress without failure, the third thermal performance. This determines how the mixture behaves under simulated cold weather conditions. The collected data was analyzed and compared across all mixtures. These allow identification of performance trends. Now move to the results. Now moving to the results, the testing procedure several important findings. The data indicated that there are significant differences in performance between the tested mixture. Some mixtures show much higher crack resistance compared to the other. This why the primary due to increased flexible and improved stress distribution. The modified mixture generally perform better than the conventional mixture. This suggests that the material modification can significantly enhance low temperature resistance. In the result table shown here, we can observe the mixture with improved binder characteristics demonstrate lower cracking sustainability. This confirms that the binder selection is critical factor. The result is all show that the aggregate structure influences resistance by affecting internal stress concentration. Now move to the discussion. These findings align with observations reported in the previous literatures. The improved performance of modified mixture can explain by their ability to absorb thermal stress more effectively. When asphalt retains flexible at low temperature, it can deform slightly without cracking. This reduces failure risk. The result also demonstrates the optimized HRA design required balancing stiffness and flexibility. If the mixture is too stiff, cracking increases. If it is too flexible, structure stability may be reduced. Therefore, the best performance mixture are those to date achieve this balance. This is the particular implication for pavement engineer. It showed that the careful mixture for design can significantly improve pavement durability. Research significance. The study contribution to pavement engineer in several ways. First, it provides specific insight in HRA performance under low temperature conditions. Second, it offers evidence supporting the use of modified binder to optimize design. The third, contribution toward more sustainable infrastructure by helping reduce performance pavement failure. Longer lasting payments mean lower maintenance costs, reduce material consumption, improve environmental sustainability. Now move to the conclusion. In conclusion, the research demonstrates the low temperature cracking is a critical challenge for hot roll asphalt. The study confirmed that the mixture composition has a major influence on cracking resistance. The findings show that optimized binder selection and material modification significantly improve performance. This means engineer can reduce cracking risk by selecting appropriate material during pavement design. Ultimately, improved HRA crack resistance will result in the stronger, safer, and more durable roads. Recommendation future work. Based on this recommendation finding, I recommended the further research in this area. First, field validation should be good conduct to compare laboratory finding with real payment performance. Second, long-term monitoring should be carried out. Third, additional modification and innovation materials should be explored. These steps will help you further improve asphalt payment performance. Now closing. This conclude my presentation. Thank you very much for your attention, and I welcome any question and comments. Thank you very much.